This is group 6. I'm going to introduce our project called a low-cost system for measuring, counting, and monitoring parcels. Here is a diagram which describes the system. Ultrasonic resonance 1 is used for counting and measuring the heat, the length of the parcel. The length of the parcel is computed by multiplying the speed of the conveyor belt and the calculated moving time of the parcel and the ultrasonic resonance. Ultrasonic resonances 2 and 3 are used for measuring the width of the parcel. Since we only have one ultrasonic resonance, the ultrasonic resonance 2 and 3 are not available in our real experiments. The computer 7 runs the graphical user interface, which receives measured dimensions from 1 to 3 and images from color camera 4 through multiple USB cables. In this picture, you can see the ultrasonic resonance, the color camera. Here is our graphical user interface. It shows the width, heat, length, and also the number of parcels past the ultrasonic resonance. About the calibration of the ultrasonic resonance, we calibrated the sensor at a maximum of 2000 millimeters. We found that when the distances between the objects and the ultrasonic resonance increase, the raw signal becomes unstable, as shown as these red data points. So if we directly apply the least squares fitting algorithm to fit this noisy data points, the fitting error is quite high. So we adopt a random sample consensus-based algorithm to first extract the inliers, the good data points from the noisy data point, and then apply the least squares fitting algorithm. You can see that the fitting error decreased dramatically. About the methods for counting and measuring parcels, we found that the measured distances of a parcel when it passes the ultrasonic, it will first decrease and then increase. Based on a predefined threshold, we can detect this decrease and increase phenomenon, and to count the parcel when it passes the ultrasonic sensor. Also, we can determine the exact duration time, multiply this duration time and the conveyor belt speed. We can calculate the length, and also to estimate the heat for the parcel robustly. We also apply a RNSAC based method to estimate the length robustly. Here is the accuracy and the repeatability of the heat measuring. We measured 3 parcels with a heat of 48, 220, and 331 millimeters. You can see that the mean error and the standard deviation are quite low. And also, we tried 30 times. The counting method counted 30 parcels. It works quite well. About the length accuracy, in this experiment, the time interval of the ultrasonic sensor is set to 50 millimeters, and to achieve an accuracy of 10 millimeters in the length accuracy, the speed of the conveyor should should be set to a maximum of 20 centimeters per second. About the minimum recommended parcel size, we recommend 50 millimeters for length, width, and heat because of the detection capability of the sensor, the speed of the conveyor belt, and the predefined threshold for counting the parcel. Also, the maximum parcel size is mainly limited by the installation process. Overall, the system can measure most sizes of parcels in practical usages. And this is a video shows how the system goes when it operates in a real experiment. We first open the camera. It will tell you that it is opened successfully. It will connect with the color camera and the ultrasonic sensor successfully, and then it will do the initial calibration to calibrate its original distances between the ground, also the conveyor belt and the ultrasonic reading sensor. And then we moved the parcel to pass the ultrasonic reading sensor. We tried 3 times in this experiment. When the parcel passes, it will report the heat. This is the duration time when it passes the ultrasonic sensor, and it will also count the parcel. This is the second experiment. The third experiment. The system will also store the snapshots of the puzzle and also the puzzle log file, which contains the measured dimensions. Thank you.